So area is a concept that's very important for students to understand. It's very closely related to spatial reasoning and to multiplication, division, the distributive property, etc. It also becomes very important when students get into middle school math, where they're thinking about surface area of a three-dimensional object or area of other shapes. So you can think about it like the space in between a two-dimensional object, and in second through fourth grades, which is who this video is targeted for, we are only looking at quadrilaterals, rectangular objects, objects with the straight, non-diagonal lines. So we're not talking about circles, we're not talking about triangles. Um, the area formula is just length times width. So let's talk about how this topic can be introduced to children and then some different ways to help them conceptualize it when it gets to be a little bit more difficult. Okay, so introducing the concept using real world objects is really important. So on the left-hand side, in the classroom, we do have 1 by 1 square foot tiles, which is great for showing students area of 1 square foot. On the other side, we're trying to figure out the area of the carpet, so they're thinking about tiling that carpet as well. So this is kind of a precursor to understanding the length times width concept. So we're going to kind of intermix both of these strategies throughout the video. Now, it's also important for students to understand that we don't have to just use square feet. We can use square yards or inches, centimeters, etc. So introducing them and exposing them to a lot of different units of measurement is important here. Okay, so when we're looking at this, just a rectangle that's 8 feet by 5 feet, if students are just knowing to multiply those two numbers together, then they can consistently get the right answer, but they also need to understand the concept. So tiling, which means thinking about the rectangle in terms of a tiled surface, can really help to drive this point home. So I like to show the students at first this sort of image so that they can kind of get the idea. So at first they might try to count all of the tiles, and then we can think of and try to derive easier ways for them to count the tiles, and that would just be multiplying 5 times 8. But showing them this first really builds that conceptual understanding for when we get into more difficult questions like this one. So this is where we go after the students are more solid with just finding the area of simple rectangular figures. We go to this, which is kind of called composite area or rectilinear area. Composite because it is composed of two rectangles stuck together. So helping the students to kind of see that this could be two rectangles is very important. So here they can split their shape. They could have also split it in a different way, but getting them to understand that can help with this concept. Again, I start by showing them a tiled example. Okay, so this is the way that they would figure this out. But a tiled example helps as well so that they can start to see that, and they can start to see that there are indeed two rectangles there, both of which can be counted. Understanding this is very important for understanding the next example, which is more difficult in that it uses overlapping rectangles. So here it's easy to see these are just the two separate rectangles, and the dimensions that are listed on the sides can easily be used. We have the 9 times 2 equals 18 and 9 times 6 equals 54. They just add those two areas together. 54 plus 18 equals 72 square feet for this object. They can count it if they want to, but I don't encourage that because it takes a long time. Okay, let's look at this example. This example is a little bit more difficult here because what students will tend to do is they'll split here. All right, so they're looking, they say, okay, I see the two rectangles here. I'm going to split. I have here 5 times 3 is 15, and then here 8 times 3 is 24. So take a second to look and see what the issue is with that strategy. All right, here they are looking at that 8 feet. And they're not understanding that the 8 feet represents that entire bottom length. So if they're cutting it there, then they are no longer having something that actually equals 8 feet. So this is a place where tiling really helps the students until they are able to develop that number sense. So when we're looking at this, we're actually seeing, okay, this is not 8, this is 5. So how could we have figured that out? All right, if I'm looking here, I have 8, and then I had 3 up here. So I know that if this is 3, this has to be 3 down here. And then so 3 plus 5 equals 8. So having that understanding and splitting it and making that connection is really important for the students. So this is something that we have to practice with using tiling and other strategies, but thinking about it in a more hands-on way and not just giving them rules, helping them to really see that connection there with area. All right, and then we'll see it's actually just 2 identical rectangles stuck together, and that labeling is a little misleading there.